Hi, this video introduces the concept of the pair as a data structure. It's a pretty simple data structure, but we got to start somewhere. So a pair is a data structure that holds two objects, kind of like it sounds, like a pair of things, a pair of apples or two apples. And the nomenclature in the C++ standard library is that the two elements are called the first and the second. It's kind of arguable if that's the best names for these. You could maybe say left and right, or A and B, X and Y. There's a lot of alternatives here, but they went with the words first and second, so that's what we're going to use. The data types of the two elements are allowed to be the same or different. So this is a pretty flexible data structure. I could have a pair of two ints, but I could also have a pair of a string and a float, or any other combination of two data types. And a pair always has two. So just to be clear, this is not a data structure that has up to two elements in it, but it's exactly two. So there's always two elements in a pair. Let's give some examples of some use cases. Why would you ever use this? One is it's a convenient way to return two values. As you may know, in C++, you're not allowed to return more than one value. Some other programming languages allow you to do that, return multiple objects, but not C++. You can only return one object. So a workaround, if you want to return two pieces of information, is to return a pair that has those two pieces of information. So here's a hypothetical. Let's say we have a function called ID and name that comes up with an identifier number and a string name for a person. Those are two pieces of information. It's not convenient to return them as one. I suppose we could do pass by reference. That's one reason for pass by reference. But another way to do that is return a pair where the first element is the int ID and the second element of the pair is a string. And another application would be maybe you want the minimum and maximum of a vector of ints. So a vector is a data structure that holds ints. And let's say you want not just the minimum, but also the maximum. Again, two pieces of information. One way to return that would be to return a pair where the first element is an int and the second element is an int. We would need to document which one is the minimum, which one is the maximum. Probably since it's phrased min and max with the min coming first, the first element of the pair would be the min and the second element would be the max, but that should be described in a comment. Another application is that there's a very important abstract data type called a map. We're going to spend a lot of time on that later in the class. Maps are often implemented as binary search trees or hash tables, which are very important, very efficient data structures. And a map stores every piece of information as a pair. A map connects a key to a value, and those key value associations are represented in pairs. We'll get into that in a lot more detail later. But a major reason we're introducing this now is so that you're familiar with the concept of a pair when we get to maps. And again, I just want to emphasize that the two data types for the first and second element can be the same or they can be different. I gave you an example where the first data element is an int and the second one is a string, and I gave you another example where they both happen to be ints. Both are allowed. Here's how we would describe pair as an abstract data type. So it's a pair. There are two data type template types here, T1 for the type of the first element and T2 for the type of the second element. And here is the list of operations in a pair. So this is the abstract notion of what a pair is. This would apply to any programming language, any kind of computer. And then in a moment, we'll see how this is implemented in the C++ standard library. We need a make pair function or operation that takes the first element and the second element and returns a pair, and that creates a new pair containing those elements. This is how you get a pair created in the first place. We've got accessors to get the first. You give it a pair, it gives you the data type of the first element. Get second is analogous to that. You give it the pair object, and out comes the second element of that pair. And there are setters. You can set the first and you can set the second. So pretty simple, but the point of this abstract data type notation is to define exactly what a pair can and can't do. So this is implemented in the C++ standard library. It's called pair. It's a good name. And the full name is std::pair. So what I'm going to do now is I'm going to look at the official documentation for this and point out how the std pair implements that abstract data type that was defined on the previous slide. Okay, so here we are on the C++.com technical documentation for std pair. So this is the standard template library definition of pair. So what we're seeing here is the difference between the abstract data type definition of pair. That's the general concept of a pair of two elements that was defined in the slides, and this concrete implementation of pair in the C++ language. So there's a lot that's similar and a lot that's different. What's similar is that all of the operations in that slide are going to be present here somehow. So there's going to be a way to make a pair, get the first and second element, set the first and second element. What's going to be different is there may be some additional operations. There's detail that has to do with the C++ programming language specifically, and they might call things different names or use different symbols for things. But all of those concepts in the abstract data type are here somehow if you can find them. So they say here what a pair is. That's basically the same as what we said in the abstract data type. This is C++, so we have template types. There are two template parameters. T1 is the data type of first, T2 is the data type of second. And it says here that the first element is a member variable and the second element is a member variable. This is different from the way that first and second were described in the abstract data type. In the abstract data type, there was a getter for first and a setter for first. And likewise, a getter for second and a setter for second. There was no way to manipulate those data members directly. That's the conventional object-oriented programming approach. That's encapsulation that makes it so that the user of the class cannot tamper with data members. The C++ standard library kind of breaks that tradition here and just makes the first and second data members visible. So you're allowed to manipulate them with the dot operator. So that's a design choice they made. And it's a slight difference between the ADT and the code. It's not a huge conceptual difference. If we look at the constructor, we can see that right here is the make pair operation. They just call it pair. So that's another difference. It's kind of a superficial difference. In the ADT slide, we said that the operation of creating a pair is called make-pair. Here it's got to be called pair. That's how C++ constructors have to be named. Again, kind of a superficial difference, but you give it a first element and a second element, it constructs a pair like that. There's some other ways of constructing a C++ pair. You can give one no arguments and it default constructs the first and the second. There's also a copy constructor. Those weren't mentioned in the ADT. That's fine. The implementation is certainly welcome to add some more operations if it makes things more efficient or easier to use. Here's an example of usage. So they create a standard pair where the first element is a string and the second is a double called product1. That's default constructed. So you've got the default string, which is empty, and the default double. Or you can create one with explicit arguments for the first element and the second element. That would initialize product2 to have a first element of tomatoes and a second element of 2.3. And then this here is how you access or assign the data members. We can say product2.first equals shoes, so that reassigns the first element. Product2.second equals 39.90. I guess we're saying these shoes cost about $40. And then here's how you would access them. Product1.second, product2.second, product1.first. Okay, so this is an example of how that abstract data type is implemented in C++. You can see there's additional stuff here. Another thing I want to bring your attention to is make-pair. This is a function. It's not a member function. It's just a top-level function. It's a convenient way of creating one of these pairs. So sometimes in code you'll see this. Instead of declaring a pair object and using the constructor, another way of constructing a pair object is with make pair, and you pass in the two arguments. In particular, this is convenient if you want to return a pair object. So here's an example. Standard pair in equals foo, and then foo equals make pair. This all works fine, but if you wanted to return a pair object, if all you had was the constructor, you'd have to declare a pair, construct it, and then return that on 2 lines of code. With make pair, you can construct and return a pair on 1 line of code. So that's it for pair.